Hi friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another extremely popular coding interview question. It's on Leetcode 268 missing number. So you can see from like dislike ratio, this is another extremely likable coding problem. This problem was also asked in many interviews, so that's why I'm creating this video to show you how to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Your subscription is really important and helpful for this channel. It really supports this channel, guys. So let's start. Given array nums containing n distinct numbers in the range from 0 to n, return the only number in the range that is missing from the array. Okay, so we want to find out the missing number. Uh, the constraint says that the n is nums dot length. It will be between 1 to 10 raised to 4 inclusive, and the numbers itself will range between 0 to less than equal to n. All the numbers are unique. Okay, so let's take a look at some examples, then it will be more clear. So 301, so what is the number missing? 0 1 2, 2 is missing, right? So 2 is missing, so your output is 2. 0 1, so the next number which is missing here is 2, right? So 2 is missing. I hope you are following me, right? So in the in this one you have 0 1 2 3 4 5 6 7 and 8 is not there, right? 9 is there but 8 is not there, so 8 is the missing number. Okay, so this is what the problem is asking us to find out. Okay, so I hope the problem statement is pretty clear, right? So the numbers will be in the range from 0 to n. So for example, here the numbers are from 0 to 9, and then one of the number is missing, which is 8. So you have to find out that number. Okay. So in today's session, I am going to show you a very interesting solution here that we can use to solve this kind of problem, and that is called as binary search, right? So we can apply binary search here on this problem. So let's take a look at one example that I created for you guys, so it will be very clear for you guys. So this is the array that is given to us. So this is the input array, and we want to find out what is the missing number here. So you can visually solve here. So 0 1 2 3 4 5 6 is not there, right? 7 8 is there, 6 is not there. That's why answer is 6. Okay, so now you know that why 6 is there and what the problem is asking us to do. So one thing we will do is, first we will take this input array and we will sort this array. So this is how the sorted array will look like to us, right? So 0 1 2 3 4 5 7 8. Okay, so this is the sorted array. Now we will apply a binary search on this sorted array, right? And why the binary search will work here, that I will show you clearly, right? Then it will be very clear. So let's draw one quick thing here so that it will be clear for you guys what we are doing here, right? So 0 1, then 2, then 3, then 4, then 5, then 6, and then 7, right? Okay, so what we did here, guys, is we draw the indexes here for this one, right? So these are the indexes for the of the sorted array. Okay, so let me take it here so it will be more readable. Okay, now what we will do in the binary search, we have a left pointer, right, and we have a right pointer here, right, and we always go to the middle. So middle will be, for example, 3, right? So I'll go to the middle 3. I will check if this 3 and this index actually of the array, are they matching? Yes, they are matching here, right? They are matching, correct? So it means that 3 is at the correct position. You understood this, right? 3 is at the correct position. Why this one is work? Because the numbers are from 0 to n range. Okay, very important. The range is always 0 to n. So 3 I found at 3 index, which means that these numbers are already sorted in a correct way, so they cannot be missing basically. So 0 1 2 and 3 are already there. It means that they cannot be missing because 3 is at index 3. Okay, so this is clear to you. Now I will apply a binary. I am applying binary search. So what will happen? Left will go here now, right? Left will go here because I know that there is no point to take a look at left because they are already there, all these numbers. Okay, I'll check again. I'll go to the midpoint. The midpoint is now at 5. I'll check if the index of 5, right, and the value here is same. Yes, 5 and 5 is same. It means that this 4 and 5 is already there, so there is no point to check here. So now what I'll do, I'll put my left here basically. Okay, Now again I will go to the mid position. Now my mid position will come here. Okay, I will check if these values are same. No, index is 6 but the value is 7. You understood this, right? Index is 6, so I am expecting 6 there, but the value I am seeing there is 7. It means that value 6 is missing basically, guys. Okay, it means that value 6 is missing. You understood, right? I am expecting 6 at index 6, but I am seeing 7. It means that value 6 is not there because this is a sorted array. Okay, so this is how we can solve this problem. Since we are using binary search time complexity is log n, but the problem here is not problem, but the more prominent factor I would say is n log n is going to be your time complexity, because we have to sort that array, right? Sorting takes n log n time. Okay, so let us go ahead and take a look at Java code, then it will be very clear for you guys. So missing number is what we are implementing. A nums array is given to us. This one is going to return an integer, which is the missing number. First thing we are going to do here is sorting that nums array, which takes n log n time. This is only required when the array is not sorted, but more or less likely it won't be sorted, so we have to sort it. Okay, after that we'll take two pointers. This is how binary search work. Left is 0, right is at the end of the array, right? Nums.length -1. While left is less than equal to right, you get to the midpoint. So left plus right minus left divided by 2. So this is standard implementation of binary search. You find out midpoint. Now you are checking if your current midpoint, if it is greater than midpoint, correct? If it is greater than midpoint, it means that your missing number is on your left side. You understood, right? Your current value, if it is greater than your mid value, it means that your missing number is on the left side. Then you have to go to the left side. So right will be mid -1. Otherwise, left will be mid +1. It means that your missing number is on the right side. Then you have to go to the right side basically, correct? I just shown you here how we have decided where to go, right? When you are at 3, you know that 3 and 3 are matching. Then you decided that if you want to go to the right, because it's not greater basically, so you want to go to the right side, right? So this while loop will keep looping, and it will come out at the end. Your left pointer will tell you, you see here, your left pointer will tell you which value is missing basically, correct? Okay, so this is it, guys. So this takes, let's write down the time complexity and space complexity for you guys, so it will be very clear for you. So it's n log of n, right? N log of n, where n is a total numbers given in the nums array. Okay, and why? Because of the sorting. Okay, and space complexity for this code, guys, for you is order of 1. This is also known as constant. Okay, because we did not use any extra space, we just used couple of variables do not count towards space. So this is a constant on space solution, guys. So very good solution. So let's give it a run. Make sure it compiles and runs against the test cases correctly. So here you will see that 2 is correct answer, and here 2 again correct answer, and here 8 correct answer. Submit this code now to Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see, the code is successfully accepted. I'm not sure about these numbers. Let's try to resubmit this one more time, guys. Okay, I'm not sure about the numbers, but this is the way you can solve this problem on Leetcode 268. Missing number, a very important problem that we have solved by using binary search. And I hope that the explanation and this example help you understand the concept of how you can apply binary search to solve these kind of problems. If you like this example, then try to be generous, guys, and give a like for this video. Subscribe to our channel, click on the bell notification icon button so you won't miss any important postings from our channel. Share this video with all your friends so they will also watch new ways to solve different varieties of coding problems. On this channel, we create content and videos to help others learn more computer science programming concepts along with data structures and algorithmic paradigms. We have more than 600 solved coding problems, which are problems asked in interviews by Amazon, Apple, Microsoft, Google, Meta, Yahoo, and lots of big companies. And we came up with very important playlists that you should watch right away. The names of those playlists from this channel includes graphs, matrices, binary search trees, binary trees, Problems solved by using very important techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices and trees. The important data structures related playlist we have created for you guys include stacks, queues, priority queues, min heap, max heap, arrays, array lists, linked lists. So everything is here. So go check out those videos. You will definitely learn a lot from them. If you are a Java consultant, we also have created videos for you that discusses frequently asked Java telephonic interview questions and how to answer them. That discusses core Java questions, Java J2E questions, questions related to Hibernate, JPS, Spring, and lots of other auxiliary technologies. So they will definitely be helpful for you. And if they help you, then don't forget to write down in the comments. That really inspires us to create more such good quality content for others. Thanks for watching this video and have a great day ahead.